Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In this video we will solve together a new problem, problem number 4. Given the function f defined as f of x equals x squared minus 2 plus ln x, see its representative curve in orthonormal system, we have to calculate limit f of x as x goes to 0 plus. As x goes to 0 plus 0 minus infinity, so minus infinity. Let us see limit f of x as x goes to 0 plus x square 0 and ln x minus infinity, this is minus infinity. What do we conclude? We have a vertical asymptote x equals 0. Limit f of x as x goes to plus infinity. As x goes to plus infinity, this plus infinity directly. F prime of x equals 2x plus 1 over x greater than 0, because the domain of definition is 0 plus infinity. So the function is strictly increasing. Plus minus infinity to plus infinity. This is the table of variation. Show that the equation f of x equals 0 admits a unique root alpha and alpha between 1.3 and 1.4. This question constitutes of two parts. First, we have to prove that f of x equals 0 admits a unique root. Second part, we have to prove that alpha between 1.3 and 1.4. How to prove an equation admits a unique root? We have to prove it changes the sign, strictly monotonic and continuous. Okay, f is a continuous function and strictly increasing over 0 plus infinity. F of x changes the sign from minus infinity to plus infinity. Then f of x equals 0 admits a unique root alpha. We have to prove that alpha between 1.3 and 1.4. So we have to prove that f of 1.3 times f of 1.4 is negative. Okay. Prove that C admits an inflection point I to be determined. Inflection point. We have to prove that f second of x vanishes and changes the sign. Let us calculate f second of x. F second of x is 2x squared minus 1 over x squared. 2x squared minus 1 had the form of a squared minus b squared. So this is a minus b into a plus b. Radical 2x plus 1 over x squared positive. So f second of x take the sign of radical 2x minus 1. Which vanishes at x equal 1 over radical 2 equal radical 2 over 2. And radical 2x minus 1 changes its sign, because here we have a first degree factor and no minus, so the table of signs start by what? 1 factor, and 0 minus, the table start by minus, so we have minus 0 plus. Then the second derivative changes the sign and vanishes at x equal radical 2 over 2. So the curve of FC admits an inflection point of abscissa radical 2 over 2. How to calculate y of I? F of radical 2 over 2. We substitute. So this is ln radical 2 over 2. It means ln of 1 over radical 2. It means ln radical 2 to the ln radical 2 to the power minus 1 means ln 2 to the power minus half. So this is minus half ln 2. Okay. The inflection point I is radical 2 over 2 minus 3 plus radical 2 minus 3 plus ln 2 over 2. Determine the points of C where the tangents to C are parallel to the straight line dy equal 3x minus 4. Okay, let M be a point on the curve where the tangent is parallel to D. The slope of the tangent is f prime of x equals slope of D equal 3. Let us see. So here we have a quadratic equation. If we substitute x by 1, we got a root. The second root is 1 over 2. 1 over 2. You can use your calculator. Or you can use the discriminant delta, because here we have a quadratic equation. How to calculate the y of m1? We substitute. This number is equal to f of 1, and this number is equal to f of half. Study the sign of f of x. Study the sign of f of x. The function f is strictly increasing. And it changes its sign from minus infinity to plus infinity at alpha 0. So between 0 and alpha, f of x is negative. From minus infinity to 0, negative numbers here. Plus alpha plus infinity. Here we have the numbers above 0. Means the numbers greater than 0. So the sign of f of x between alpha plus infinity is a plus. Calculate limit f prime of x as x goes to plus infinity and construct C. Limit f prime of x as x goes to plus infinity equals limit 2x plus 1 over x as x goes to plus infinity. This is plus infinity. 1 over x 0 plus infinity. What does it mean? Limit f prime of x as x goes to plus infinity equals plus infinity. So we have an asymptotic direction parallel to y prime y. Here is the curve of f. The curve cuts x prime x between 1.3 and 1.4. Consider the function g defined over 0 plus infinity as g of x equal x minus 2 plus 1 minus ln x over x. U its representative curve. Calculate limit g of x as x goes to 0 plus. Limit g of x as x goes to 0 plus equals how much? Okay, this is 0. 1 minus ln x as x goes to 0 plus ln x minus infinity minus infinity plus infinity over 0 plus. This is plus infinity. U admits vertical asymptote x equals 0. Prove that d prime y equal x minus 2 is an oblique asymptote to u. First we have to calculate limit f of x as x goes to plus infinity. It should be plus infinity. Limit g of x as x goes to plus infinity equal limit x minus 2 plus 1 minus ln x over x as x goes to plus infinity. X plus infinity, 1 minus ln x over x 0, so plus infinity. Limit g of x minus 2. When we subtract x minus 2 from g of x, we still have 1 minus ln x over x. And this limit is equal to 0. The straight line of equation y equals x minus 2 is an oblique asymptote to u. Verify that g prime of x equals f of x over x squared. G prime of x So g prime of x equals derivative of x is 1 minus 2 0 u over v, u prime v minus 1 over x times x minus u v prime minus into 1 minus ln x. This is how much? Minus 1 minus 1 minus 2 minus 2 plus ln x minus 2 plus ln x over x square, common denominator. So this is f of x over x square. G prime of x takes the sign of f of x. Express g of alpha in terms of alpha. G of alpha equals alpha minus 2 plus 1 minus ln alpha over alpha. So we have to get rid of ln alpha. How to get rid of ln alpha? Alpha is a root. We go back to alpha. Alpha is a root of the equation alpha square minus 2 plus ln alpha. Ln alpha equals 2 minus alpha square. We substitute ln alpha and we get g of alpha in terms of alpha. So we substitute ln alpha 2 minus alpha square minus ln alpha minus 2 plus alpha square over alpha minus 2. Here we have alpha square over alpha. This is alpha and alpha 2 alpha. Minus 1 over alpha, 1 minus 2 minus 1 minus 1 over alpha and plus and minus 2. 2 alpha minus 1 over alpha minus 2. Calculate g of alpha if alpha equals 1.35. This is approximately minus 0.041. G of alpha is negative. Set up the table of variation of g and the sign of f of x minus y of d prime. So we have to set up the table of variation and the table of sign of f of x minus y d prime. G prime of x takes the sign of f of x, so minus 0 plus, decreasing, increasing, g of alpha plus infinity plus infinity. Okay, limit g of x as x goes to plus infinity, and limit g of x as x goes to 0 is also plus infinity. F of x minus y d prime 1 minus ln x over x, same sign as 1 minus ln x. 1 minus ln x equals 0 for x equal e. 1 minus ln x is positive for x less than e, because here we have minus before ln x. 1 minus ln x negative for x greater than e. It means above the oblique asymptote 1x less than e, and it's below the oblique asymptote if x is greater than e. We have to deduce that g of x admits exactly two distinct roots. As you see here, g is continuous over 0 plus infinity, over 0 alpha strictly decreasing at the change of the sign because g of alpha is negative, over alpha plus infinity strictly increasing at the changes of the sign. Then g of x admits two roots, one between 0 alpha and the other between alpha plus infinity. G of alpha negative, then g of x changes its sign 2 times, hence g of x equals 0 admits two distinct roots. Calculate g of 1, g of 1.7, g of 1.8, construct u, c, and d prime. G of 1, if we substitute x by 1, g of 1 equals 0. So 1 is a root. So this is the root before alpha. G of 1.7 is negative, g of 1.8 is positive. So g admits a root between 1.7 and 1.8. 1.7 and 1.8, this root is after alpha. the curve of u, curve of u, curve of c, and d prime. This is d prime. D prime, the oblique asymptote. The curve u cuts the oblique asymptote. Cut the oblique asymptote between 0 e. The curve is above the oblique asymptote, and between e plus infinity, the curve is below the oblique asymptote. We studied this before. Study the sense of variation of the function h defined over 0 plus infinity as h of x equal g of x square. G of x square. Let us see the curve of the function g. This is u, the curve u. Curve u cuts x prime x at 1 and at a number between 1.7 and 1.8, between 1.7 and 1.8. G of 1.7 negative, we are below the x-axis. G of 1.8, 0.03, we are above the x-axis. Then there is a root between 1.7 and 1.8. In this question, we have to set up the table of variation of the function h defined over 0 plus infinity as h of x equals g of x square. The domain of the function is 0 plus infinity, and we have to calculate h prime of x, then the limits. H prime of x equals, this is u square, 2u prime, 2g of x times g prime of x. H prime of x takes the sign of g of x times g prime of x. This beta is between 1.7 and 1.8 because g of 1.7 is negative, g of 1.8 positive. Okay, g prime of x. The function g decreasing, then increasing. The function g decreasing from 0 to plus infinity, then increasing. So, g prime of x negative, negative, positive, positive. G of x here, the curve of u, the function here is decreasing, then increasing till alpha. Here we have the alpha, and the curve of u cuts the x-axis at 1 and beta, beta between 1.7 and 1.8. Okay. So g decreasing, then increasing, then minus, minus, plus, plus. G of x, the sign of g of x. G of x vanishes at 1 and beta, between 1 and beta, and the curve is below x prime x, so plus, minus, minus, plus. Their product, minus times plus, minus. Here 0 times number 0, 0 times number 0, 0 times number 0, so we have 3 zeros here. This table shows us the sign of h prime of x. Now we are going to set up the table of variation of the function h. Limit h of x as x goes to 0. As x goes to 0, g of x goes to what? To plus infinity, square plus infinity. Limit h of x as x goes to plus infinity. G of x goes to plus infinity, so this plus infinity. Plus infinity, g of alpha square plus infinity, and at 1 h of x equal what? 0, because h of x equal g of x. G of x vanishes at 1 and beta, then h of x vanishes at 1 and beta. Thanks for following and good luck.